Differentiation. Differentiation is the process of transforming a function into its derivatives, average and instantaneous rate of change. Consider the graph of y is equal to x squared below. The average rate of change between P and Q is the gradient of a straight line from point P to Q, that is y2 minus y1 over x2 minus x1. The instantaneous rate of change at point P is the gradient of a tangent at point P, that is AB. The gradient function of y is equal to x raised to power n. Again, consider the graph of y is equal to x squared. It means for a point xy, we can replace y with x squared, thus having x squared since y is equal to x squared. The gradient of AB is change in y over change in x, that is x plus h squared minus x squared over x plus h minus x. We multiply and open the bracket, and finally we end up with 2x plus h. As b moves closer to a, h approaches 0, and therefore it can be ignored, and thus we have 2x. 2x is the gradient function of the curve y is equal to x squared. Thus, this function can be used to find the gradient at any point on the curve by simply substituting the values. For example, at point 11, the gradient is 2 times 1. At point 32, the gradient is equal to 6. For a curve y is equal to x cubed, the gradient will be x plus h cubed minus x squared over x plus h minus x, finally giving us 3x squared plus 3hx plus h squared. But h approaches 0 as points move closer, and thus can be ignored, giving the gradient function of y is equal to x cubed as 3x squared. Again, this function can be used to determine the gradient at any point on the curve. In general, the gradient function of y is equals to x raised to power n is given by nx raised to power n minus 1, where n is a positive integer. For example, the gradient function of y is equal to x raised to power 5. N is 5, and hence we have 5x raised to 5 minus 1, giving us 5x raised to power 4. Y is equal to x raised to power 8 will give us 8x raised to power 7. The gradient function of ax raised to power n. Generally, the gradient of a function y is equal to ax raised to power n is given by na times x raised to power n minus 1. For example, y is equal to 2x raised to power 6. a is 2, n is 6, and therefore we shall have 12x raised to power 5. Y is equal to minus 3x to power 4. We shall have minus 12x raised to power 3. The delta notation. We have used h to represent a small change in x. The symbol delta is used to indicate a small change, that is, delta x is a small change in x and delta y is a small change in y. Note that delta x is not the same as delta times x. Delta x is a single function. We can now obtain the gradient function of a curve using delta instead of h. Consider a curve y is x squared again, as shown below. The gradient of AB is delta y over delta x. The coordinates of A, x squared, and B, x plus delta x plus delta x squared. Delta y over delta x will give us 2x plus delta x. As B moves closer to A, delta x approaches 0 and can now be ignored. Hence, the gradient function of y is equal to x squared is 2x. The process of deriving this function is called differentiation. That is, differentiation of x squared with respect to x. The gradient function is called the derivative or derived function of x squared. When delta x approaches 0, delta y over delta x becomes dy over dx, where dy over dx means derivative of y with respect to x. The symbol d over dx means derivative with respect to x of. Thus, when y is x squared, dy over dx is equal to 2. For instance, to find the derivative of y is equal to x cubed, we write dy over dx is equal to d over dx into bracket x cubed. Similarly, to find the derivative of x raised to power 6, we write d over dx into x raised to 6 is equal to 6x raised to power 5. That is, we differentiate x to power 6 with respect to x. Derivative of a polynomial. A polynomial in x is an expression with terms that have different powers of x. For example, 3x squared plus 2x plus 1 and x to power 4 plus x cubed plus 2x squared plus 3x minus 5 and so forth. Consider y is equal to x cubed plus x squared. To find its derivative, take any points and find the gradients. That is, A with coordinates x cubed plus x squared, and B x plus delta x plus delta x cubed, and x plus delta x squared. delta y over delta x will ultimately give us 3x squared plus 3x delta x plus 3x into bracket delta x squared plus 2x plus delta x. As delta x approaches 0, we ignore delta x and delta x squared, and therefore delta y over delta x becomes dy over dx. Therefore, dy over dx is 3x squared plus 2x. Thus, d over dx of x cubed plus x squared is equal to 3x squared plus 2x. Generally, the derivative of any polynomial is the derivative of each of its terms with the operations combining the terms retained. For example, find the derivatives of the following. In our solutions, d over dx for the first one is equal to 12x to power 5 minus 16x cubed minus 6x. For b, d over dx is equal to 20x to power 4 plus 6x squared plus 6x. To find the gradient of a curve at any point, say when x is equal to 1, we simply substitute x into the gradient function. That is 20 into 1 to power 4 plus 6 into 1 squared plus 6 into 1, which gives us 32. Equations of tangents and normals. A tangent is a straight line touching a curve at one point. Normal to the tangent at a point is a straight line perpendicular to the tangent at that point. We can determine the equations of a tangent to a curve as well as that of the normal. For example, find the equations of a tangent to a curve y is equal to x squared minus 5x plus 6 at a point 0, 6, and the equation of its normal at the same point. In our solution, we obtain the gradient function dy over dx, which is equal to 2x minus 5. Next, substitute the x-coordinate into the gradient function to get the gradient at that point. And when x is 0, dy over dx is equal to minus 5. This is the gradient of the tangent passing through 0, 6. Recall that the equation of a straight line is given by y is equal to mx plus c, where m is the gradient and c is the y-intercept. Then the equation of the tangent with gradient negative 5 passing through 0, 6 will be y is equal to minus 5x plus 6. Recall also that for perpendicular lines 1 and 2, gradient 1 times gradient 2 is negative 1. Thus, if gradient 1 is negative 5, then gradient 2 is 1 over 5. Take a point xy and the point 0, 6 and equate to the gradient. Therefore, y minus 6 over x minus 0 is equal to 1 over 5. Multiplying, we end up with the equation y is equal to 1 over 5x plus 6. This is the equation of the normal to the tangent of the curve at a point 0.06. Stationary points. A stationary point is a point where the gradient is 0. That is, dy over dx is equal to 0. Consider the figure below. At point B, the gradient is positive to the left and negative to the right. Therefore, B is a maximum stationary point or turning point. For C, it is the opposite of B. C is a minimum stationary point. For D, both the left and the right have positive gradients. D is a point of inflection. It could also be both left and right have negative gradients. For example, find the stationary points of y is equal to x cubed plus 12x plus 1. Determine the nature of the stationary points. In our solution, if y is x cubed minus 12x plus 1, then dy over dx is 3x squared minus 12. Dy over dx is equal to 0 at stationary points. Therefore, equating 3x squared minus 12 is equal to 0, we shall have x is equal to minus 2 and x is equal to 2. Substituting in the original equation, when x is minus 2, y is 17. And when x is 2, y is minus 15. Stationary points are therefore A minus 2, 17 and B 2 minus 15. What are their nature? Considering A, the neighborhood of minus 2 is minus 1 and minus 3. When x is minus 3, dy over dx is equal to 15. And when x is minus 1, dy over dx is equal to minus 9. Clearly, the gradient changes from positive to negative. We conclude that A is a maximum stationary point. Considering B, the neighborhood of x is equal to minus 2 is 1 and 3. When x is equal to 1, dy over dx is minus 9. When x is 3, dy over dx is equal to 15. The gradient changes from negative to positive, and B is therefore a minimum stationary point. In summary, the curve has a maximum point at negative 2, 17 and a minimum point at 2 minus 15. This information can be represented in the table below. Sketching curves. When sketching curves, the interest is only to get the general shape and the features of the curve, that is, the x-intercept, the y-intercept, and the stationary points. For example, sketch the curve of y is equal to x squared minus x minus 6. In our solution, factorizing the above, y is equal to x minus 3 times x plus 2. When x is 0, y is minus 6. When y is 0, x is equal to minus 2 or minus 3. The y-intercept is therefore at 0, minus 6. The x-intercepts are minus 2, 0, and 3, 0. Stationary points dy over dx, we equate the equation to 0. Therefore, 2x minus 1 is equal to 0. X is a half. When x is a half, and using the equation y is equal to x squared minus x minus 6, y is equal to minus 6 and 1 over 4. The stationary point is at a half and minus 6, 1 over 4. The neighborhood of x is equal to a half is x is equal to 0 and x is 1. When x is 0, dy over dx is equal to minus 1. And when x is equal to 1, dy over dx is equal to 1. The gradient changes from negative to positive, and hence it is a minimum stationary point. This information can equally be represented in the table shown below. We can therefore finally obtain a rough sketch of the curve as indicated below. Differentiation in kinematics. Velocity. Assuming the distance d covered by a moving object after t seconds is given by d is equal to 5t plus 12. Recall that y is equal to mx plus c, where m is the gradient. Thus, from d is equal to 5t plus 12, 5 is the gradient of the straight line. We can obtain this by differentiation, that is, differentiation of d with respect to t is equal to 5. d over dt gives us the velocity of the object. For example, the distance s in meters covered by an object after time t is given by s is equal to 2t squared minus 4t. Find its velocity at t is equal to 2. Find the time when the object is at rest. In the solution, velocity is equal to ds over dt, that is differentiation of distance, which is 4t minus 4. When t is equal to 2, v is 4 meters per second. An object is at rest if v is 0, hence ds over dt is 0, meaning that 4t minus 4 is equal to 0 and t is 1 second. Therefore, the object is at rest after 1 second. Acceleration. When we differentiate velocity function, we obtain the acceleration function. For example, S is equal to 4t cubed plus 3t squared minus 4t plus 5. V is ds over dt equal to 12t squared plus 6t minus 4. Acceleration A is equal to dv over dt equal to 24t plus 6. Maxima and minima. Consider the figure below. The shaded area are equal squares. Suppose the shaded squares are cut and the figure folded along the dotted lines to form a box. What will be the maximum volume? In our solution, assuming the squares have dimensions of x by x centimeters, then the box will be as shown below. Volume is given by 8 minus 2x times 5 minus 2x times x, which is 4x cubed minus 26x squared plus 40x. Maximum volume occur when d volume over dx is equal to 0. Therefore, dv over dx is equal to 12x squared minus 52x plus 40. 12x squared minus 52x plus 40 is equal to 0. Solving the quadratic equation, x is 1 or x is 10 over 3. When x is 1, the dimensions are 6 by 3 by 1. When x is 10 over 3, the dimensions are 4 over 3 by minus 5 over 3 by 10 over 3. The second solution cannot be true because dimensions can never be negative, and therefore maximum volume is 6 times 3 times 1, which is 18 centimeters cubed.
You can make a bigger difference in the world. You can make a positive change in your career. You can make a greater contribution to the greater good. And you can start today by earning your degree online at Walden University, where advanced degrees advance the quality of life.